Hi everyone, so today I'm going to, just discuss a topic and discuss how little we know maybe about a topic. So this is diets and loricariidae, and I've done so many videos on it, and some things are really sort of clear, like Panax, Panaculus. They're feeding most likely on sort of microbes rather than the wood itself, so they're not xylivores. They do fit under detritivorous, and it's really difficult to actually film a video given how little I think we know and how little is actually available. For some reason it seems like there's this massive disconnect between what we actually know scientifically about their diets and what the hobby says about their diets. For example, I did film a video on hypencystrus diets, where if you look at the journals, from memory they feed a lot on plant matter, including seeds, particularly in one species, and also in detritus, but very little actually insect matter. They're not carnivores. Only one species, from memory, actually fed on insects. And a lot of species haven't had that sort of really intense studies into their diets. There's such a wide diversity of loricariidae, but with that diversity, they must be avoiding competing in some way for their food, and a lot of them are algivores and detritivores, which is really important to actually recognise in their diet. There are many things in their wild diets we cannot cater for in captivity, such as sponges, which take such a long time to grow, and also maybe the diversity of algae, bacteria, even the other microorganisms. And while I say very few are carnivores, it's because it's really difficult to actually categorise this in aquatic ecosystems, because sponges are animals, as are rotifers, bryozoa, and these almost, while they're not photosynthetic, so they're definitely not plants, which is really a dodgy way of putting it, because algae are photosynthetic, but their algae go into so many different categories, and nutritionally they'd be very different to actual plants. Very few actually feed on as many plants as people think, and this isn't catered for in captivity, and it's really researching it. There are papers available, but there's so much we can't, or it's very challenging to cater for, and a lot of diets feed the same thing as other fishes, even though it might label it for plecos, loricariidae. It doesn't actually cater for them. They largely contain a high amount of fish meal, insect meal, or krill meal, which might be put under fish and fish derivatives, krill and krill derivatives, that sort of thing, which the two fish and krill meal actually have a really high environmental impact, and also it's nothing like their wild diet. Very few eat sort of the higher level of insects that maybe even the insects meal is catered for, and certainly not hypencystrus. When we look at a lot of the diets, they contain a high amount of vegetables, potatoes, peas, a lot of cereals. I don't know, cereals, are they vegetables? Probably not. But this doesn't reflect the wild diet and doesn't cater for the diversity even in the slightest. And when it comes to algae, usually it seems like spirulina is the main one, along with Corellia. I can visualise the word, not pronounce it. Which makes it really difficult to actually cater for. And while there's two diets that actually cater for the majority of loricariidae, which is Rapaciosaurine green and New Life Spectrum, the green algae one, I'm not a fan of it. It's the smell and the colour doesn't look right. I've got loads of algae meals. I haven't actually done that much with them, but the smell is quite strong. And if you go to the seaside and you're picking up seaweeds, which are macroalgae, they do smell pretty bad. I know they're rotting, but they do have an odour. And a lot of these diets, a lot of diets in captivity focus on these things. And I wonder whether this is why we see a high mortality. A lot of people have said fishes or loricariids, the females or males even, aren't fertile after a few years. And when we look at other animals, diet is so key to fertility, because if you're not getting the right diet, fertility will be easily missed. And also growth. Sometimes they aren't fed. Panax, I think, are a particularly bad one for a slow growth rate in captivity. And whether this is partially because they're fed so much wood, people rely on wood more than anything, or I don't know, because they're not, I wouldn't say they're generalists, they're sort of specialised detritivorous in a way, just by how they get their food. But when I've fed them a lot of food, they tend to grow a lot quicker. Another aspect maybe is the amount of food in general. If you're thinking of the grazing species, they're probably feeding every day. And while in captivity, are our foods as nutritional? I don't know. And I would say probably not as nutritional as the wild. Maybe a little bit more. It's really difficult because there's no studies actually on feeding the fishes, like fishery studies that I've seen anyway. So it's really difficult to gauge how much they should be feeding, but Barry and Citrus in theory would be feeding all day. In captivity, when you look at animals, take horses, a lot of their food will be sort of very low nutrients, but they'll be feeding all the time. Hence why you feed sort of hay, but they're more fibrivores, like guinea pigs. I'm not a horse diet expert at all, or I haven't worked with horses in a while. But you could kind of compare, even though I'd say the aquatic resources are probably a lot more nutritious, especially algae. We know with human diets, when you're feeding algae to people, they contain a lot of protein, a lot of vitamins and minerals. The only risk is obviously you can overdose. Proteins are a big one. So I'm going on many different tangents here, but when people say proteins are a wide diversity of different molecules. Anyway, and generally they are built of amino acids, which are nitrogen based. Just weird thing, I don't know why. But different amino acids come from different sources, so you can't say this diet's high in protein, so it's therefore better, because you've got to look at what proteins and therefore what sources. Some proteins only found in more animal and bacterial sources. I believe B12 originates from bacteria that then is almost, you get it then from animals and stuff like that. Whereas there's other amino acids that you can only get from plants or algae, and this is why it's particularly, there's a lot more to think about than saying high and low protein, and that's why I look so little at those percentages, because generally when you're feeding too much protein, that's just going to come out in or maybe even the wrong proteins, that's just going to come out as ammonia. That if there's too much, the fish is just going to be waste. So I don't know why people focus so much on that. Sometimes I think it's a lot about big claims. You see, I don't know why a lot of brands have been doing wood-based diets, even though I know Repashi's one that's been out for a long time, at least over maybe 6-7 years, and one of the major papers have been around maybe 10. Well, the last major one I think was 2020-2021 that showed that there's no point feeding cellulose, and the digestive benefits seem like whether there is or not digestive benefits wouldn't make sense, if you get what I mean, because why would Panax and Panaculus Latin citrus and hypostomus, we use it for digestive benefits when no other detritivore is. And microbes are quite easy, I would say, to digest, opposed to maybe those that are feeding on insects, which you got chitin, which is really difficult to digest. But the main point is that we don't understand the diets that well, but they do feed on this wider diversity of periplankton, algae, microorganisms, even detritus. So maybe looking at detritivores from another aspect that we're not quite, how we would cater for it in captivity would be really difficult. But I think these would be key to getting a higher, well, a lower mortality. These fishes living decades, growing as they should. No way should Barian citrus be that small for that long, even Panax. And while there are strategies in nature, such as you see in sharks, that or mammals, every animal, that you kind of do the, they take so long to reach maturity, which sexual maturity, I mean, not just maturity in general, and that's just slow in general. But I don't know if it makes sense. We know so little about these fishes' biology, I think, and how we can cater for it in captivity. And that's certainly, we need to look more into their diets and subdividing those algivore, all of them. Maybe it'd be nice to, I don't know, there are documents you can get that show what we know so far about what the fishes are eating. Of course, it's very vague and doesn't include them all. Even within the same genus, you'll have a diversity of diets, and when you look at jaw shape, that's really reflected. So hypostomus, I was reading a paper and I would like to share it, but the permissions bit is a bit complicated. But it shows that they're feeding on a diversity of different diets depending on the species within hypostomus. You see the same in ancistrus of jaw shapes, and therefore they must be feeding on different things. And there's so many species found in the same area, they need to avoid competing. So how can we cater for that in captivity? And there's no point having loads of different pleco foods when they all contain the same ingredients or similar ingredients. It drives me nuts. Which is why I support the diets I do. And maybe looking more into detritivores. Substrates, I think, are important. This is the second paper I've seen that quite a lot of loricariids use they have a lot of the substrate in their gut. Whether it's sands or more silts or whatever, because a lot of these are detritivores as well. And if you're feeding on rocks in fast flowing areas, you're not going to get that much substrate sands because it's just going downstream. But that could be really useful for dietary benefits, and it'd be really interesting if people could compare bare bottom tank to one with substrates of the same fish, Pterophytes, whatever, just because it's easier, and comparing how they're growing and growth rate on the same diet, same amount of food, same temperatures, that sort of thing. It'd be nice to see a little bit more, like maybe, citizen science, community science, and also interesting papers. These fishes cannot be left alone in a tank just to feed on nothing. You see so much stunting and short lifespans. There's a lot of bloat, and a lot of people say, oh, the protein issue again. But maybe look at the right proteins, and also maybe for the right species. Even when housing species together, think about what they're feeding on. And the other's food in a way, which is really difficult with captive diets. Unless you have a gigantic aquarium and you could provide that much sort of more natural interesting to see, well, I don't know, more aquariums that allow for more of an ecosystem anyway. Well, not an ecosystem, they're not. But like having an interest also in the other organisms in the aquarium, whether it's bryozoa, rotifers. Actually, rotifers is one thing that is in their diets that you can get actually as a frozen food, but is a marine rotifers. That's actually probably an important point to make when you're looking at diets, and I think I made it on algae. Just because it says algae doesn't mean it's the same algae. Just because it says bloodworm, which is chlorinated, is it larvae? Basically midge larvae. It doesn't mean it's the same one. And there is a study on what's the things, species of killifish, looking at captive diets, and it showed they were carnivores, but they had a very poor growth rate on bloodworm. And captive diets dry foods, gel foods, can provide a lot more minerals, vitamins, and that's very important to recognise. Compared to if you're just providing even like 20, well, let's say 5 or so frozen foods. And also access to fish meals. If the fish is not piscivore, which a lot of loricariidae won't be, they probably won't be able to access a lot of the nutrients from fish meals compared to if they were. And phosphorus, I think, was mentioned. If the fish isn't a piscivore, it's unlikely to be able to access that phosphorus from, I think it was phosphorus from the bones and stuff of the fish. And when we're looking at that, think about what the fish is naturally eating, because that's what it's evolved to do. That's what it's got the enzymes and bacteria to do. The longer a fish has been in captivity, though, it might have lost some of this ability to, like you see with people where their diets have changed, so their gut biota changes, maybe from gut morphology, I don't know. So really thinking about how long this fish has been in captivity, and whether this will cause part of the problems later on in life, because this fish might not be able to digest as well as one that's only recently been caught. So treatments, there's a bit of tangent and it's kind of just guessing in a way. But by providing as early on the best diet, the better chance you have for that fish in captivity. A lot of them still are wild caught, and that's really important to recognise. We do know, I would say in other animals, the diet of the parents is really important for the juveniles in general. And where are they getting this gut biota if they are captive bred? Most likely it will be related to the parents, I'd assume, through the stool, through feces. I'd assume that's where quite a lot will be available. So thinking about the whole chain, I wonder whether introducing wild fish with captive bred will change things. And there's so much influence of diet on gut biota having this bacteria, archaea, stuff like that. And we really need to start thinking. It's a really interesting topic, just looking at it. And also thinking about looking at the fishes and maybe what they might be doing with this morphology. Obviously some morphology, so body shape will be related to phylogenetics, so this is the evolution, so related to who the fish is related to him, is the easiest way to say it. So say all Ancistrus have most Ancistrus have tentacles. I'm not going to say all because who knows. But generally it's a defining feature. Does this mean the tentacles are, if a species has tentacles, is it functional or is it due to its relationship, and to what extent is it either? You could say the same about diet. Is this fish's morphology related more to who it's related to, or is it functional? Functional being, is it useful for them feeding and doing whatever they're doing? So there's a lot of food for thought, and we need to start, I think, discussing with a lot of fishes, discussing, especially when we're looking at, a lot of captive diets are the same for a lot of fishes, and we're not growing them for food. We don't need efficient diets. We want a fish that's going to live a long, healthy, happy life. Happy bit isn't probably the wrong word. So maybe we need to start looking at that more than anything. And yes, colour is important to a degree, but just healthy. And maybe not always whether it's entirely really fast growing, but a healthy, sufficient growth, if you get what I mean. Anyway, so I'm going to finish this here. I'll be happy to discuss the topic, particularly on the Facebook groups, just because it's easier for me to access on my phone. Anyway, thank you for watching. If you like my videos, please comment, subscribe, like, whatever. I know my videos, the comments get turned off a lot automatically by YouTube. I don't know whether it's the wet specimens, the taxidermy that triggered it, or whatever. But if you comment on one of my other videos, or comment on Facebook group or whatever, I should be able to work it out and turn it back on till it gets switched off again. Anyway, thank you for watching.